All right, today we are starting a new chapter, and we will be working all the way through to the last day. I'm teaching every single day. Do not miss this. It all depends on whether you are working hard as to whether I give you a test. Okay, so if you're showing me you're working hard, I probably won't give you a test. If you are not working hard, because I could use it for the beginning of the school year grades. If you are not working hard, I will give you a test. So let's try and just work hard at this, learn it. All right, this is chapter 9 of the Green Book. We are back in the Green Book, chapter 9. So this is section 9.1, and the purpose of today's lesson. This chapter is very important. A lot of this chapter really kind of gives us the glue for domain and range, which is a huge theme in algebra. So in particular today, we are looking at finding intersections and unions of different kinds of sets. Okay? Intersections and unions. We'll be dealing with some new words, roster and set builder notation. All right, so here we go. All right, a set is a collection of members or elements. So when I'm talking about a set, we're looking at members or elements that are part of a group. So let's look at the set of colors in the rainbow. Can anybody tell me the set of colors in the rainbow? Go.
It's Roy G. Biv. Red, orange, yellow, green, blue, violet. No, indigo, violet.
Indigo, what'd you call it? Roy G. Biv?
Roy G. Biv.
Roy G. Biv. Okay, Roy G. Biv. Good, Roy G. Biv. Red, orange, yellow, green, blue, indigo, violet. These are all elements, or we could say members of that group. Okay, what about the vowels in the alphabet? A-E-I-O-U. Good. How about our Beatles? The set of the Beatles.
George Harrison, Ringo Starr,
Thank you for raising your hand. Can you tell me?
Paul, George, Ringo, and John.
Okay, I'm just going to tell you, you really need to know them in the way that we say them. Because you don't really have to say the Beatles, because all you really have to say is John, Paul, George, and Ringo. Everybody say that. John, Paul, George, and Ringo. John, Paul, George, and Ringo. It's like almost like one word.
favorite song.
Ready? No, we're not talking about favorite songs. We're just doing John, Paul, George, and Ringo. John, Paul, George. Okay. All right, so the Beatles. It's actually an embarrassment that you guys don't know that, but you don't know that it's an embarrassment, but just the godfathers of rock and roll. All right, now that I'm taping this, please know your Beatles band members, okay? What about a set that has no members? Can you think of a set that has no members? Go.
I don't know. I was going to say one that has one member, but no.
How about, I didn't ask for it, I asked for a set with no members. How about, yes.
Okay. Panic at the Disco members other than Brendan Urie. 0 members.
A soloist.
No.
Is Panic at the Disco,
The band.
and
Good job, Nina.
is there,
He's the only one.
he's the only person in the band?
Other than him, there are no members.
They all left because of Northern Band Tour.
Oh, okay, guys, I'm recording. So how about I'm looking for 6-foot students in my class?
0.
0. That would be a group with 0 members. How about a spider with 10 legs? They don't exist. So that would be what we call, and we call this an empty set because there's no members in that set. Yes?
A backpack with 3 straps.
Good, exactly. A backpack with a 3-strap backpack. All right, so now let's take it to numbers. We've got 3 sets here. Okay? The first types of relationship we're going to look at are intersections. And this is the symbol. You need to write this down. And you need to write, we call this an and statement. Write that word and down. An intersection is the elements that are common in both sets. So for an intersection, it has to be only, the new group will only be what's in common. Does that make sense? So if I am looking at the intersection of A and B, what do they have in common? How about Max?
They have
Anything else?
2 and 4.
Yep. And so the way I would write that intersection is I would put it into the braces. Okay? Because remember, braces imply a list. And so the list of solutions to this would be 2 and 4, because those are the only two that are in both set A and set B. Does that make sense? So that means that little symbol that's upside down, kind of looks like a horseshoe, is what's in an intersection, what's in common. What would be the intersection of B and C? Let's go with Nicole. B and C.
6 and 8.
B, the intersection, they both have 6. Good, and they both have 8. Perfect. And I would put it into the braces. Okay, why don't you try number 3? Go. Everybody go. And Fiona, what did you come up with?
A and C both have 5.
They both have 5, yes. All right. Now look, it starts to get a little bit more complicated. So I have A intersecting B. What are the elements of that set? I want you to list them. What is it?
A intersecting B is 2 and 4.
2 and 4. And what are the elements of C, or the members of C? Go.
5, 6, 7, and 8.
And what do they have in common?
Nothing. It's an empty set.
Nothing. We call that an empty set, and there's 4 different ways that we can write that. Okay? We can write that like 2 braces with nothing in it. We can write the word empty set. We can use the 0 with a slash through it, which means null set. Or we can use the word null set. All of these mean there's no members. Okay, so now we're going to talk about unions. Everybody write the word union. This is an or statement. This is an or statement. This is the combined set of elements from 2 sets with no duplication of elements. Meaning, we just combine the 2 sets. You don't have to be in common. So if I'm looking for a union of A and B, and I don't write any duplicates, if I want to combine A and B, what would it be? What would the new union be? What do you think, Brianne?
Would it be
Sorry.
2, 3, 4, 5, 6, 8, and 10?
Yep. It'll be, so I'm going to take everything from A, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I've already used 2. I've done 4. And then I'm going to do 6, 8, and 10. Does that make sense? Yeah. So union is when I combine them. Okay, pause the recording, and I want you to write the unions for B, U, C, and A union C. Okay, let's check our... So you said 2, 4, 5, 6, 7, 8, 10. An A union C? How about Jamie?
1, 2, 3, 4, 5, 6, 7, 8.
1, 2, 3, 4, 5, 6, 7, 8. Good. Yes, I'm understanding. No, I'm not. Okay, we're going to skip the Venn diagrams.
That's easy.
They get really complicated. Really complicated. So the union would be the whole thing. Would be covered in. There we go.
We do this in English.
Huh?
We're doing this kind of diagram in English.
Oh, you are? So when you have three different sets and nothing's in common, that would be the center part would be shaded. That would be the empty set. Because what do these three sets have that's in common? Versus, look at the last one was A intersecting B. A intersecting B. A and B right here. Right? And then intersecting with C. Oh, it's A union, so 5, 6, 8. Sorry. See, I already did it wrong. Anyways, we're going to skip this. I don't want to get into this because it's going to take too much time. All right. So now let's talk about our sets on the number line. If I look at the set of all real numbers greater than -4, how would I show that on a number line? What do you think we would do? Mike?
Open circle and -4 going to the right.
Going to the right. Open circle, going to the right. And what about set Y? How would I show all real numbers less than or equal to 1? Go, Elise.
You would put a filled in circle on 1 and then go to the left.
Good. Now, look at this one. This is what we're really kind of talking about here. All real numbers between -2 and 3. All real numbers between max.
Would you put an open circle on -2 and on 3?
Yep, and then connect the points. So that shows every single number greater than -2 but less than 3. Is everybody remembering how to do that? Okay, well the Z part is new. If I were showing this, bless you, if I were showing this with an inequality, what would the inequality look like for the first one? Yep.
It would be x is greater than 4.
Good. And what would the second inequality look like? -4, yeah.
-4.
What would the next one look like? Somebody else? Grant?
X is less than or equal to 1.
Good. And then the last one, what's it going to look like? Okay, Max?
-2 is less than Z, which is...
Well, it's set Z, but we're still using, because the set name is Z, but we're still talking about the members as X, which is less, keep going. Does everybody remember that? Yeah. I kind of introduced it. We're going to need it this chapter. We don't really need it for this one. I'm just adding that. So, 2 different ways to write it. We talked about function notation before. Notation means writing. So, set builder notation is a new type of writing, the way we talk about it. Roster notation is what we've been doing, listing the numbers in order. 1, 2, 3, 4, 5. Set builder, we would read like this. We say, everybody follow me. Okay? We say, when you see that little colon, we say X is such. Everybody repeat after me. X is such. X is such that. X is a natural number. And X is less than 5. Less than or equal to 5. So when I say X is such that, I can use the colon or I can use a line. Does that make sense? All right, so now I'm moving on and I'm going to set builder notation. Okay, so roster notation is where we list the numbers. Set builder notation is really how we talk about the group they're from, and then we just write the group that they're part of, and we use the inequality to describe them. Okay, so if I were talking about set B, what would I say? Same thing, same starting. What do we say? Everybody?
X is
Such that X is it a natural number? Are they natural numbers? is a natural number, comma, and what else? What inequality would I use to describe that?
And 4 is
Less than
x is less than 7.
4 is less than or equal to
Less than or
x,
equal to x.
which is less than or equal to 7. Is that making sense? Are you taking notes?
Yeah.
Okay. Yes, Jamie.
Alright, could you have done 3 is less than x, which is less than
Yes.
8?
Mm-hmm. Absolutely. Yep, we absolutely could have. So, now, does everybody understand the difference between roster notation versus set builder notation? Now we have to combine that with unions and intersections. So, when I'm looking at roster notation to describe the following, what does this mean, this upside down horseshoe? That's an intersection. I don't necessarily memorize intersection, but I know when it's a U, it stands for union, right? So I know the other one, if it's not a U, is intersection. All right, so when we're looking at the intersection, what it's really asking is, what is in A and B? So what's in A and B? What?
4 and 5.
4 and 5. Whereas when I'm looking at a union, the real question it's asking is, what is in A or B? 1, 2, 3, 4, 5, 6, 7. It can be in one or the other. Do you understand the difference? Okay, questions? All right, moving on. Okay, so state the domain of X in roster notation and set builder notation. This direction reading gets to be very important. Okay, because if you're not paying attention and where does it say to put roster notation? A. So you have to know what roster notation looks like. And you have to put it next to A. If you put it under B, you get 2, 4, 6 points wrong. Do you understand on a test? Mm-hmm. So you got to know the language. Okay, so this is what you're going to be doing for homework. Now, I also want to show you this little symbol right here. Do you see it? Yeah. That means is an element of. E for element. Same thing as a member. Okay? So in roster notation, when we are looking at X as an element of the whole numbers and is less than 5. They give us kind of two boundaries. In roster notation, what are those numbers that are whole numbers less than 5? What's
3, 2, 1, 2, 2, 4.
What's the lower boundary?
1.
No.
No, 0.
0. 0 is part of your whole numbers start at 0. 0, 1, 2, 3, 4. Do I include 5?
Nope.
Because it doesn't say less than or equal to. And then what would we write in set builder notation? Okay, here's what we're going to do. We're going to say X is such that X is, right? And then you list the group they're part of. A whole number. You copy what they said. And for this part, put it into an inequality. And X is less than 5. You could just copy the whole thing in words, but it takes longer. So use the inequality for this part. Does that make sense? I want to take a break for a minute, and I want to go back and review some number groups. Okay? Our natural numbers are what numbers? 1, 2, 3. So it has a natural boundary. When you use the word natural, the boundary means it starts at 1 and it goes on forever. Then we got a little bit bigger. We grew up and we went to school and we got to whole numbers. And whole numbers include the same thing but 0. right?
Integers.
Then we get a little bit bigger and we go to integers. And those are -3, -2, -1, 0, 1, 2, 3. So 0 is an integer and a whole. Then we get older and we go to rationals. Our rationals are any number that can be written as a fraction. So that includes all decimals, right? We can write that as a decimal. What about a repeating decimal?
No, that's irrational. Oh, wait, no, that is. No.
What fraction is that?
1/3.
1/3. So the definition of a rational number is any number that can be written as a ratio of two numbers. Okay? And now we are, and so this could be the square root of 9, because that really simplifies. So these are all our number groups, and then out here we have our irrationals. Irrationals. And our irrationals are like pi,
Square root of 2.
square root of 2, the square root of any number that's not a perfect square. 1 is rational. The square root of 1 is a whole number. The square root of 1 is 1. And the square root of 0 is 0. So they're perfect squares. And together, these two make up the real numbers.
And then imaginary.
As opposed to our imaginaries out here, the square root of -1. These are imaginaries.
How do you even work with imaginary?
Yes, you can.
Wait.
But we're not going to deal with them today.
11.
Okay, so is everybody clear here?
Yes. Exactly, it's imaginary.
Okay. So now, we did our whole numbers. We said x is an element or a member of the whole numbers and is less than 5. We've done this one. Next one, x is any integer between -3 and 2. So what are we writing for our roster notation? How about Harrison?
So you're gonna write -3.
Between.
Oh, okay. So yeah, -2, -1, 0, 1, and that's it.
Good. Okay. And then b. B. What would be for our set builder notation? Who wants to tackle that one? Don't all volunteer at once? Okay, Elise, you want to do it?
No.
Okay, Eitan.
I'll try. So all natural, it would be 1,
No, we don't. We start with always the same thing that I taught everybody to say.
0.
No, go. That was, you're giving me roster notation. I'm looking for set builder. What?
Is such that.
X is such that, whoops, I don't need is. I'm using our set builder notation. Is such that
X.
is
Any integer.
an integer.
Is an integer.
And, comma, and, what am I going to write here? What's the inequality for that?
Isn't it -3 is less than x, which is less than -2?
Perfect. So I write the rule that they gave me, and I use an inequality to discuss this. What do you mean? Because because this is the lower. It's a number in the middle. It's less than 2, but isn't x greater than -3? So it's somewhere in between there. It can't be -3. It can't be 2. It's somewhere in the middle. Okay, you want to try the next one on your own?
Yeah.
Go. Pause the recording. What do we have for A? I want to hear from people. Brianne.
1, 2, 3, 4, 5, 6.
Good. 1, 2, 3, 4, 5, 6. Because our naturals start at 0. Okay, set builder, Jamie.
X is such that x is a natural number and x is less than 7.
Perfect. Now, why don't I need to write an in-between statement here? Why didn't I have to do 1 is less than or equal to x, which is less than 7? Why don't I need to do that, Chloe?
Because it just says that it's less
less than 7.
It's less than 7, but the other boundary, yeah, Tony?
Natural number.
The other boundary, instead of writing 1, natural numbers implies that it starts. That's why I don't have to. If you had written that, I wouldn't have marked it wrong. So that's another way. You could have said, and 1 is less than x, which is less than 7. But natural number implies the lower boundary, because our natural numbers start at 1. Does that make sense? Okay. All right. Use the sets below to find the following in roster notation. So we're going roster notation, just listening. What would what is that? What is it? Who wants to read number 1? How about Mike?
Oh. Okay. What did you do? Intersection?
Mm-hmm.
So,
A intersects B.
yeah.
And you should be writing this, Nicole. Okay, what does that mean to be an intersection?
I mean, which numbers are common? But
What's in common with the whole numbers and the B numbers? What's in common? Mike?
there is no common?
Yes, there is. There is something in common.
Oh, 0.
0 is in common. Good. 0 is in common. Because in our whole numbers, they start at 0, 1, 2, 3, and so on, right? Okay, next one. Fiona, read it.
B is a union of C.
B union C.
Or B
What is it?
union C. All members in both.
What are they?
Oh, -1, none. Oh, wait, -3, -2, -1, 0.
None?
What?
Wait, -3.
-2, -1, 0, 1, 2, 3, 4.
Okay. Next one, Nicole.
B and C is
B what? What does that symbol mean?
the intersection.
B intersecting C.
Is
What is intersection? What?
there's nothing.
There's nothing. We're going to leave it an empty set. And we would never do this. That's a double empty set. It's a double negative. So you have to either do one or the other, but not one inside the other. Okay, next one. Let's go with Isabel. Read it first.
A union B.
Okay, and that would be?
That would be negative 3.
A union B. Okay, yeah, -3.
-2, -1, 0, and then 1, 2, 3.
And so on. Once I'm in the positives, I use ... That means everything else. Okay, what about C? I mean, number 5. How about Grant?
Okay. A intersects C.
A-
That would be 1, 2, 3, 4, and it would be on.
Oh, yeah. 1, 2, 3, 4, on, he says. And so on. Etc. Okay, questions? All right, that's the... Yes.
For number 4, doesn't holes not include negatives?
That's correct.
So then why did you have -3, -2, and -1?
Because it's a union.
Because you were mixing the holes in that.
Oh,
Because it's a union, not an intersection. Does that make sense?
yeah.
Gracie.
In 5, it wouldn't actually be ... because it's
Oh, you're right. What was I thinking? So it's an intersection. It's only what's in common, and the only part that are in common, you're right. I saw all those hands shoot up. Okay, that is the end of the video.